Hello. Now we are going to be doing graphing. I am pretty positive we went through the second one that you emailed me. Let me get that up since I have exited at this point. Okay, I'm pretty sure we went through the cosine one. So now I'll record me going through these step by step, and then I believe I can do a screen record of me plugging these into Desmos. But I mean, that's the least complicated part of this problem is plugging these into Desmos. And we'll get you to the part where you plug into Desmos. And then you can just look at the multiple choice answers for these questions. So if I can't figure that out, I apologize. But we'll at least walk through the setup of these problems. These were pretty straightforward when we went through the cosine one last week, I believe. So these weren't too horrendous, which is nice. Our very first one is just going to be graph using a Taylor polynomial. Our function is going to be just simply ln of x, and this is going to be centered at a equals 0. Again, just demonstrating that these are approximations, especially in the format that they ask for. So they want the Taylor polynomial. T sub 3, I believe is how you would pronounce that. So this means they want 3 derivatives in their equation. Whether it is 3 terms or 4 terms, they want 3 derivatives to be in their equation. That's what this 3 means. I triple checked that we absolutely need 3 derivatives when the t is 3. So if we do this, if we don't have a Taylor series that we've been working with previously where we put n's into our equation and stuff like that, if we only have a specific amount of terms, then this is only an approximation that is only going to be accurate for a very small section of the graph, normally only 1 or 2 units, I would say. So that's why I feel like that clearly demonstrates what this number actually means for these questions, that we want that approximation. We want to utilize a different looking function at that specific point rather than this function for whatever reason. But it is going to be our closest approximation at 1 rather than at 0 or at any other point. So that's kind of another explanation for what that is. So we are going to be utilizing the same formula. All of our formulas need to include derivatives. So my preferred method is just going derivatives, plugging in our a, and then plugging it into the formula. So we'll just kind of keep going with that process. I feel like it's the most straightforward. Get all of your information first. So our first derivative of ln x, I believe that is going to be 1 over x, or x to the negative 1. So we can derive this again, and then that's going to be negative 1 x to the negative 2, or negative 1 over x squared. We'll kind of keep both because we're going to need to plug in a number for these anyway, and these regular forms kind of help us when we're plugging in. So we'll kind of keep them there like that, if you can see that. Okay, and then we need our third derivative. That is going to be 2, positive 2, x to the negative 3, or 2 over x cubed. All right. With all of our series, we are just going to be plugging in a for all of these numbers. So we need ln of 1, which is going to be 0. That's just from knowing what our ln's are. We need our first derivative of 1. That is going to be 1 over 1, which is 1. Our second derivative is going to be negative 1 over 1 squared, which is negative 1. And then our third derivative is going to be 2 over 1 cubed, or 2. Yep, that's what I got last time. All right, so I think it's nice to go back to our formula for our Taylor series. Going to be n equals, well, we're not actually summing this to infinity, so we don't actually need to include that part in this formula, but we just need our nth derivative of a over n factorial times x minus a to the n. Stuff popping up on my computer. So now we're just going to go out to our third derivative. We're always going to start with our 0th term, basically. I guess what's this? N equals 0, and we're gonna go out to 3 is where we're gonna go. So I guess that's the correct notation there. So we're going to plug in 0. Factorial is going to end up being 1. This term over here is going to end up being 1 because anything raised to the 0 is 1. And this term actually ends up being 0 because our function itself ends up being 0. So this is actually only going to have 3 terms in it. Yeah, so this is going to be, our T3 is going to be 0 plus, we have 1, because that is our first derivative with a plugged in, over 1 factorial. X minus a, so that's going to be x minus 1 to the 1. All right, and then we have negative 1 over 2 factorial, x minus 1 to the 2. And then we have 2 over 3 factorial, x minus 1 to the 3. All right, so now we can do a little bit of simplification to make our lives easier. We'll do, forget about the 0. 1 divided by 1 is 1. This is just going to be x minus 1. All right, and then we have negative 1 divided by 2 factorial. 2 factorial is just 2, so it's going to be 1/2. X minus 1 squared. And then we have plus 2 over 3 factorial. 3 times 2 is going to be 6, so that is going to end up being 1/3 x minus 1 cubed. All right, so this, very funky, is actually going to be what we plug into Desmos. So I'm going to continue on with the next problem. I'll keep it in this video because why not? I think I'm only at, oh, I'm at 8 minutes already. Okay, but we'll keep it together. So erase this. I'll keep my formula for my series. And we're going to be doing something else. So what problem are we doing next? We did our cosine already. So now we just need f of x equals e to the x. And we still need our Taylor polynomial t sub 3 of x. And this is also going to be centered at a equals 1. Yes, exactly. So we love an e to the x, especially for these examples, because our derivative is just going to be e to the x. So I'm going to fly through this one. F prime, double prime, triple prime. It's going to be e to the x, e to the x, e to the x. Love these. Our a is going to be 1. So our regular function is going to be e to the 1, which just ends up being e, Our first derivative is going to also be e. Our second derivative is also going to be e. And then our third derivative is also going to be e. We love that. So now we are going to plug these in. When I plug in 0, 0 factorial is 1. This is going to be raised to the power of 0, which is also 1. So our first term actually ends up being just e, because we just wanted our 0th derivative or our regular function with 1 plugged in as our a. So this is actually just going to be. And then we have all of these terms are going to be the same in the numerator, which again is fabulous. And this is going to look very similar to our last problem that we just did earlier in this video. 1 factorial, x minus 1 to the 1. And then we have e over 2 factorial, x minus 1 to the 2, plus e over 3 factorial times x minus 1 to the 3. All right. And then the only simplification that we can really do here is just get rid of our factorials. So we'll just say e plus e divided by 1, which is just e, times x minus 1, plus e, 2 factorial is just 2, x minus 1 to the 2, and then e over 3 times 2 is 6, x minus 3, x minus 1 to the 3. All right, and then here, this is now going to be what we plug into Desmos and end up graphing, because these are just our constants. X's is just going to be our variable. So yeah, put that up for another sec. Yeah, not too bad. All right, so I'm going to try to figure out screen share, and we'll see what happens.